Detailed explanation of centripetal acceleration examples. An object moving on a circular orbit is said to be in centripetal acceleration when the acceleration of that object is concentrated towards its center of rotation. The centripetal acceleration is a constant scalar quantity. Even though its magnitude remains constant, there will be a regular change in the direction due to the position of the object changing. This section gives a brief explanation regarding the above-listed centripetal acceleration examples. The motion of the satellite around the Earth. Satellites can efficiently revolve around the Earth due to centripetal acceleration. The satellites are largely influenced by the Earth's gravity, which is constantly pulling the orbiting satellite towards the center of the Earth's gravity, which causes the satellite to achieve centripetal acceleration. Planetary motion. All planets trace a circular path to revolve around the Sun, which is one of the excellent centripetal acceleration examples. While revolving around the Sun, the acceleration of all the planets concentrated towards the center due to the exertion of mutual gravitational attraction between the planet and the Sun. A runner running around an oval track. When a runner runs on an oval track, his speed is influenced by the Earth's spin, and thus, his acceleration is pointed towards the center of the circular path. The friction evolved between the shoe of the runner and the track is also one of the reasons for possessing the centripetal acceleration. The motion of the motorbike around the circular path. In order to trace a circular path by a motorbike, centripetal force is essential, which is provided by the friction between the tire and the road. The centripetal force thus generated contributes to the exertion of centripetal acceleration on the circular path, where the acceleration of the motorbike is concentrated towards the center. A whirling stone. When a stone is tied with a string and made to rotate then above your head in a circular path, the acceleration of the stone while it is whirling is one of the excellent centripetal acceleration examples. The force from your hand creates the tension in the string, which supplies sufficient force to the stone whirl over your head. The gravitational is also provides sufficient force for stone to be concentrated towards the center, possessing centripetal acceleration. Tetherball. The motion of the tetherball is directed by the two forces which equally contribute to the ball acquiring centripetal acceleration. The ball moves more rapidly in a circular path if the centripetal force is more, which in turn requires more tension. A discus throw. Have you ever watched discus throw in the Olympics? If yes, did you know that throwing a discus is one of the very good centripetal acceleration examples? Yes, when the athlete is ready for discus throw, he constantly rotates his head with the discus around him. By that time, centripetal force is generated on the discus. If he throws the discus properly, it attains acceleration by increasing its velocity with his body. The acceleration of the discus is pointed to the center of the path it is traced while in the hand of the athlete, thus it can attain peak velocity as soon as it is released. Turning a car in a curved path. Turning a car on a curved road requires centripetal force to be exerted. The friction acting between the tire and the road causes the centripetal force on the car, which enhances the centripetal acceleration while moving. The centripetal acceleration of the car is more in the sharp curves, i.e., circular path of a small radius. If the car does not acquire the centripetal acceleration, then there is a chance for the car to take a larger radius and leave the roadway. Ride in a merry-go-round. The rider in the merry-go-round can experience the centripetal acceleration even though it has no angular acceleration, because the entire acceleration experienced by the rider on the merry-go-round is pointed towards its axis of rotation. This acceleration is always parallel to the radius of its circular path and is often referred to as radial acceleration. Ferris wheel. The physics behind the Ferris wheel is directly based on the centripetal acceleration. The passenger in the Ferris wheel can feel heavier or lighter depending on their position due to centripetal acceleration. The passenger seat of the wheel is always pivoted freely from the rim and directed downward even though the wheel spins. Twirling a lasso. While twirling a lasso, the cowboy rotates the lasso in a circular orbit, creating a sufficient amount of tension in the lasso, which contributes to generating centripetal force to rotate the lasso in a circular motion. This centripetal force governs the centripetal acceleration of the lasso. Salad spinner. The centripetal acceleration exerted on the salad spinner is similar to the washing machine. The outer wall of the spinner exerts a centripetal force on the lettuce that pushes them towards the center of rotation. Thus, the acceleration of the salad spinner is directed towards the center, resulting in centripetal acceleration. Electron revolving around the nucleus. Like the solar system, the nucleus in an atom is at the center, and all the electrons revolve around the nucleus in a circular orbit. Some positive charges surround the nucleus, and along with the negatively charged electron, an electrostatic force is developed inside the nucleus, which is intended to provide centripetal force for the electron to sustain the revolution around the nucleus, which enhances the centripetal acceleration. The Moon orbiting around the Earth. The Moon is the Earth's natural satellite, which tends to retain in the circular motion around the Earth. The Earth's gravitational attraction on the Moon is responsible for the generation of centripetal force, which is sufficient for the Moon to exert centripetal acceleration to orbiting around the Earth. Industrial centrifuge device. Industrial centrifuge devices are often related to centripetal acceleration. This device spins liquid in the test tube at high speed and generates a centripetal force that enhances the liquid's centripetal acceleration inside the device. This technique separates a mixture of two different liquid samples of different densities. If the centripetal acceleration is high, then it is easy to separate the samples. Two different layers of liquid settle in the test tube after centrifugation. The centripetal acceleration thus generated in the centrifuge device is relative to the acceleration due to gravity. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.